So we have now another sprint test problem. So this is question number 26 on the national test. So what is the smallest prime number p such that p squared minus 26p plus 1 is divisible by 167? Oh my goodness. Okay, so like the number is 167, which is actually not a nice number since it's a larger prime number. So we really cannot use the Chinese remainder here or some other stuff easily. So maybe what we are gonna hope for, like to get something nicer from this expression, but at the same time, this is a quadratic, so we are gonna kind of expect to use the quadratic mod, but it looks like it's not gonna be easy to deal with either. But anyway, so like since we have like this is even number and this is like money quadratic, so maybe we can make this complete square and maybe simplify a bit this part. So what we are trying to do, like something like this, like p squared minus 26p plus 1. We want this to be divisible by 167, so that should be converted to 0 mod 167. That's like what we are trying to do, and we want to know what is the smallest prime p. So like if I complete square right here, like that will be like half of this will be 13. So I do expect like p minus 13 to the second power. So like when you expand this, you got p squared and you got minus 26p, also 169, the square of 13. But there's no 169, so there's like 1 right here. So we need to actually have 169 with minus, so we can actually cancel that plus and minus to get just 1. So that's equal to, I'm converting to 0 mod 167. So if you don't buy this, like it's just a complete squaring process. So and then we got the p minus 13 squared. So that's 168. So like I can just say this is converting to like 168. But since we are talking about the mod 167, this is actually one more than this, meaning that this is converting to 1, which is actually nicer because I can just find the some like squares that will give us 1 when you take mod 167. So like now think about this, like what number should I square so I can get 1 mod 167? So like I can say like this might be the inside might be a p minus 13, could be like 1 or negative 1, because if you have 1 squared will be 1, negative 1 squared will be 1 as well. So either one does work. So that should be mod 167, right? And if you add 13 to both sides of the congruency, so the p would be 14 or 12 mod 167. So like meaning that like p is a prime number that is 14 more than a multiple of 167 or 12 more than a multiple of 167. So that then p should be like 14 plus 167, let's say k, or p should be 12 plus 167 times some multiple, which we do not know. But since we are interested in the smallest number, so like I can choose k or t 0, but that will be even number, which is not prime. So, and I'd like to get the smallest number, so I should add this guy to this guy to see if this is prime number. So if I choose t is 1, that 167 plus 12, which is going to be 179. If you go ahead and check this number, so that is actually a prime number, so that's our smallest one. So that was like too like challenging looking problem, to be honest, at first, but when you play with this a bit, as you see, it's actually a simple one. Anyway, so I'll see you in the next video.